Welcome to section 4.6, optimization. Our goal today is to solve application problems that involve maximum and minimum values. So our procedure that we'll be using today will be to introduce variables. We'll be given a scenario, we'll need to assign variables, look for how they're related, and then create a model, which is an equation that we can solve. Then we want to find our critical values, use what we've done in 4.5 to find our max or our min, and then use our solution to our model to answer the question that we're trying to solve. So let's work through a few of these to get a better idea of this procedure. Solve the following problems using the 4-step procedure. Find two numbers whose sum is 50 and whose product is maximum. So, step 1. We're going to find our max, right? I'm just going to label our max A. That is the product of two numbers. So we have x times y. This is what we're looking for, and we want this to be the max, okay? We also have the sum of these numbers is 50. So x plus y is 50. Now, what we'll do is step 2, find our critical values. So we really do need this to be in a form that we can take our derivative of. So I'm going to take my x plus y equals 50, and I'm just going to solve for one of the variables. So I'm going to have x equal 50 minus y. This is going to allow us to use x in our product. So we had said that we want to maximize A. That's the one we're going to be looking at. So I'm going to say A in terms of y. And we have x times y. This is our function. Now, because we did the work already and said we're going to rewrite x as 50 minus y, that's what I'm going to plug in over here into the x. That way we only have it in terms of y values. So A of y, we're going to rewrite x because x is 50 minus y times y. And what this gives us is 50y minus y squared. And now we can find our critical values because we have a function in terms of one variable. So the derivative is going to be, we have, oh, what did I do here? I forgot my y. 50y when we distribute. Okay, so the derivative of 50y is 50. The derivative of y squared is 2y. Remember, when we find critical values, this is equal to 0. So we have 2y equals 50. So y equals 25. Now, since we have a y value of 25, I can take that back over here and plug it in and find out what x is going to be. So x is 50 minus y. We said y is 25. 50 minus 25 gives me an x value of 25. Now, just to make sure, we're going to use the second derivative test to determine whether this critical value produces a max or a min. We want to make sure that it is the max. So we'll take our second derivative. The derivative of 50 is 0, and the derivative of 2y, negative 2y, is going to be negative 2. So this is less than 0, so we have a max. And so we can answer our question. The numbers 25 and 25 have a sum of 50 and give the maximum product 25 times 25 being 625. So instead of using a guess and check method or any other sort of long process, we can use what we know about derivatives to find this maximum value, almost of this number riddle. Okay, let's do another. A fence is to be built to enclose a rectangular area of 900 square feet. The fence along 3 sides is to be made of a material that costs $14 per foot. The material for the 4th side cost $42 per foot. Find the dimensions of the rectangle that will allow for the most economical fence to be built. So the first thing I'm going to do is draw our fence to get an idea of what we're talking about. So we're enclosing a rectangular area, 900 square feet. Three sides will cost $14 per foot. The 4th side cost $42 per foot. So if this side is X feet and this side is Y feet, and also 3 sides are $14 per foot. So if this side is a 14, this side is a 14, and this side is a 14, that means this side is going to be 42. Okay. When we see it like this, and we're trying to calculate our area, we're really just going to be calculating X times Y to get to that 900 feet. That's how we find area. But if we want to calculate the cost, we need the perimeter, because we need to know how long is each side, so that way we can multiply it by how much that side's going to cost us. So if I'm going to do my cost, then I'll have X, my side X, which is going to cost what looks like 14 and 14. So I'm going to say that that side is going to be X times 28 for the cost of those sides. And then my Y side is the 14 and the 42. So I'm going to say the cost for those is Y times 14 and 42, 56. And by multiplying 28, which is the X sides, times however long X is, that'll give us the cost of those sides, plus the Y sides would be the 14 plus 42, which is 56. So 56 times however long that Y side is will give us the cost of that. Adding those up together will give us our total cost. This is what we want to minimize. We want the lowest cost. We don't want to be paying the most. We want to be paying the least. So let's start by rewriting one of our equations in terms of one of the variables. X times y equals 900, we can rewrite as x equals 900 over y. Or if we want to, we can say x equals 900y to the negative 1. This will allow us to plug in the x value in terms of y, so that way our cost function will only be in terms of y's. So we have 28x plus 56y. We're going to plug in what we know x to be. 28 times 900 y to the negative 1 plus 56y. And if we multiply 28 times 900, then we can simplify that a little. 25,200 y to the negative 1 plus 56y. Now let's take the derivative. So 25,200 y to the negative 1 is going to be negative 25,200 y to the negative 2 plus 56. And we want to know our critical values, so we set this equal to 0. So we have 25,200 y to the negative 2 equals 56. Now remember, this means we have 25,200 over y squared. So if we multiply by y squared, we have 56y squared. Dividing by 56 will give us y squared equals 450. So y is going to be the square root of 450. We'll reduce that to 3 root 50, which is about 21.21. So if we take that and plug it back into our x value, we'll have 900 over 3 root 50, which is approximately 424.43. Now let's use our second derivative test to make sure this is a minimum. So we'll take our second derivative of our cost function. Negative 25,200 y to the negative 2 is going to be positive 50,400 y to the negative 3. And then derivative 56 is 0. So we're checking the point 3 root 50. 50,400 3 root 50 to the negative 3. It's going to give us about 5.28. This is greater than 0, so we produce a minimum, which is what we wanted. And so we can answer our question. A rectangular field that has a width of 21.21 feet at a cost of $14 per foot. And a length of 42.43 feet at a cost of $42 per foot will minimize the cost of the fence at approximately $2,970. So if we had calculated all those out, it comes out to $2,970 total. Okay, a commercial apple grower estimates from past records that if 50 trees are planted per acre, then each tree will yield an average of 70 pounds of apples per season. If for each additional tree planted per acre, up to 30, the average yield is reduced by 1 pound, how many trees should be planted per acre to obtain the maximum yield per acre? What is the maximum yield? Okay, so first we want to maximize our yield. And we want to know the maximum yield per acre, how many trees should be planted. So, we know that if 50 trees are planted, each tree will yield an average of 70 pounds of apples. And for each additional tree up to 30, the yield is reduced by 1 pound. Okay, that's our important information. So if I just put, we'll write it in terms of P and X. So in order to maximize the yield, we need to know how to calculate the yield. And the yield is how many apples will we have. So in order to count all of the apples, we're going to take the number of apples per tree and then multiply it by however many trees we have. So if we write this out in terms of the information we've been given, we're told the number of trees are 50, and every time they add another tree, the yield will go down. So I'm going to rearrange this to be trees first and then apples second, just because I want to write out what the trees are. So the trees, we're starting with 50, and we have to note every time we add a tree. And we're multiplying that by the number of apples for every tree. And the apples are 70, but they go down every time we add a tree. And so if we multiply these things, we'll have the amount of trees times the amount of apples in each tree. And we'll note that up to 30, so X can only go up to 30, so we can add only up to 30 trees. Okay, Let's write this FOILed out. So we'll multiply everything out. We'll get 3,500 plus 20x minus x squared. And this will allow us to take our first derivative to find those critical values. So the derivative of 3,500 is 0, the derivative of 20x is 20, and the derivative of x squared is 2x. We're finding our critical values, so we'll set that equal to 0. 2x equals 20, so x equals 10. Let's use the second derivative test to make sure this is a max. So the derivative of 20 is 0, and the derivative of negative 2x is negative 2, which is less than 0, so we have a max. And so the answer to our question, 10 additional trees should be planted per acre for a total of, since we had 50, now we'll have 60 trees per acre. And we'll reduce by 10 pounds the production will be reduced by 10 pounds per tree for a production. Oh wait, it reduces 1 pound. Ay, ay, ay. 1 pound per tree for a production level of 60 pounds per tree, because we were at 70. And a total production, plugging that into our function, we will get 3,600 pounds per acre. Okay. I think we've outlined everything on that one. A 400-room hotel in New York City is filled to capacity every night at $100 a room. For each $2 increase in rent, 4 fewer rooms are rented. If each rented room costs $12 to service per day, how much should the management charge for each room to maximize gross profit? And what is that max gross profit? So we want to max, and we want to maximize our profit. Remember, profit, in order to find it, we take whatever revenue and we subtract whatever cost we have. So whatever money you make, you have to subtract off what it cost you to make that money, and that's your profit. Now, since we have a 400-room hotel, and every time we increase by $2, 4 fewer rooms are rented, that means that we won't be able to go over 100 increases, right? Because it's dropping by 4 rooms every time we increase, and we only have 400 rooms. We don't want 0 rooms filled. That's the worst situation for a hotel. So we're going to keep our increases below 100. Now, let's fill in some of these. Our revenue is going to be, well, we have 400 rooms, and when it's at capacity, we're making $100 per room. So to find our revenue, we're going to multiply how many rooms we have by the cost per room. So how many rooms are filled is represented by the 400 rooms, and we'll subtract off 4 for every time we increase. Now the cost per room, it says, is $100, but we have to add $2 for every increase. X in these situations is representing an increase. How do we calculate the cost here? It says $12 to service them each day. So it's going to be $12 times however many rooms are being used. They don't have to service the rooms that are empty. So we have $12 times how many rooms are filled. Well, that's still 400 minus 4 for every increase. So now we have our function, and we can simplify this a bit by multiplying. So we'll have 35,200 plus 448x minus 8x squared. This allows us to find our first derivative. 448 minus 16x. And our critical values, we'll set it equal to 0. 16x equals 448. X equals 28. Let's use our second derivative to make sure this is a maximum. So we have negative 16, which is less than 0, so we have a max. So remember, X is the number of increases of $2. So the management should increase the price of the rooms by, and if we had 28 increases, that would come out to $56. Remember, each increase is $2, which becomes $156 per room. Remember, they told us we had full capacity at $100 per room. This is how much we should increase by. This increase results in a decrease of, when we plug that in, we'll get a decrease of 112 rooms being rented. Or we'll have 288 rooms. The profit on these, the profit will be 288 rooms rented for 156 per room minus $12 per room for cleaning. So the maximum profit will be 41,472, and that's when we take the revenue generated by these rooms at this price and we subtract off the service fees.